TOI 561b circles its star in just 1.4 days. Not a gentle rocky world, not a bare furnace already stripped clean, but a planet that may still be holding a thick veil of gas above a global magma-ocean. That is the paradox. A small rocky planet parked so close to its star that by one of exoplanet science's harshest assumptions, it should have lost everything light enough to escape. Surface volatiles? Gone. Atmosphere? Gone. What remains should be naked molten stone, like a skillet left inside a blast furnace. Yet new observations with the James Webb Space Telescope suggest something may still be hanging above the lava. The what is simple. TOI 561b appears to be a super Earth-sized rocky planet, roughly 10.5 parsecs away, orbiting a sun-like but older star. The how is where this gets strange. Webb looked for heat from the planet and found signs consistent with more than a bare rock surface. And the why now is that exoplanet science is moving from merely detecting rocky worlds to testing whether they can survive conditions we once thought were absolutely fatal. Tense. TOI 561b was first reported in 2021 by a team led by Lily Zhao using test data and radial velocity follow-up. The planet is about 1.37 Earth radii, with a mass around 3 Earth masses, depending on the fit you use. And it receives dozens of times more stellar energy than Earth. Its equilibrium temperature has been estimated above 2,000 Kelvin. That is hot enough to melt rock. Not metaphorically, literally. Iron, silicates, the minerals that make worlds solid under our feet, can become a churning ocean there. For years, the default expectation for planets like this was brutal. Get too close to a star and your atmosphere is blasted away by intense radiation, stellar wind, and sheer heat. Small planets have weak gravity compared with giant worlds, so they struggle to hold on. Think of trying to keep steam over a pot while someone points an industrial heat gun at it. At some point, the lid loses. That assumption shaped how astronomers sorted whole classes of exoplanets. Survivable farther out, stripped and airless closer in. But nature has a habit of refusing our clean categories. A magma-ocean planet does not behave like a simple rock sitting under a lamp. If the surface is globally molten, the lava itself can feed the atmosphere. Vaporized sodium, silicon monoxide, metal-bearing gases, oxygen-rich compounds, maybe even a mineral atmosphere in equilibrium with the melt below. In other words, the world may not be keeping an atmosphere left over from birth. It may be continuously making one from its own surface, like a road that keeps evaporating into the air and then condensing back down. Whispering, that is the part I find hardest to shake. We tend to picture planetary death as a clean ending. Atmosphere gone, geology exposed, case closed. TOI 561b hints at something more stubborn. A planet can be wounded by its star and still keep rebuilding a skin. So what did Webb actually see? Not a postcard image, not clouds drifting over lava. Webb studies exoplanets by inference, by teasing tiny changes out of heat and light. In recent observations, astronomers used the mid-infrared instrument to measure the thermal emission from the dayside region. If TOI 561b were a bare rock with no substantial atmosphere, the hottest point should sit very close to the point directly under the star, and the temperature pattern should look extreme. like one side of a cast iron pan under a blowtorch, while the rest trails behind in perkness. Instead, the emerging interpretation is that the thermal behavior may be better explained if a thick atmosphere is redistributing heat and blanketing the surface. Not proof in the courtroom sense, but enough to force a serious rewrite of the old expectation. Some models also allow a bare rock with unusual reflectivity or circulation in molten material, so the debate is not over. Yet the very fact that atmosphere-bearing models are competitive here is the shock. So let me ask you this. If you had to choose right now, which explanation sounds more convincing for TOI 561b? A thick atmosphere over lava? Or exposed molten rock with no real sky? Tell me why. This is where the story grows beyond one planet. TOI 561 is not some newborn chaotic system. Its star is old, estimated at roughly 10 billion years. That matters. If this inner world really has maintained or regenerated a substantial atmosphere for an immense span of time, then close-in rocky planets may be more chemically resilient than we thought. Not safe, not pleasant, but not instantly erased either. And there is a deeper reason astronomers care. We talk a lot about habitability, but before you can discuss life, you have to understand survival. What kinds of rocky planets can keep gases? Under what temperatures? At what gravity? For how long? TOI 561b sits near an important boundary. It is almost like finding a tree somehow rooted in the crack of a furnace wall. We would not call the place friendly, but TOI 561b sits at a fascinating rim of changeable worlds. We do not know yet what the intricacies are above its surface, but scattering light through its atmosphere is one of the only ways to learn more. And that is what will make James Webb worth every ounce of waiting and worry. You would call the tree informative. There's also the compositional puzzle. If an atmosphere exists there, what is it made of? Probably not a breathable blend. More likely a heavy, mineral-rich envelope, perhaps dominated by rock vapor species, and molecules born from constant exchange with molten silicates. On Earth, atmosphere and crust feel like separate layers. On this planet, they may behave more like two states of the same wound. Liquid below, vapor above, endlessly cycling. Can you imagine weather made partly of stone? Professionally, I think that possibility is more fascinating than another simple hell planet headline. A bare lava world is dramatic for 10 seconds. A lava world that should be bare, but may have found a way not to be, is a genuine scientific problem. And science gets most interesting when a problem refuses to stay in its assigned box. But wait, there is a twist buried inside this result. If TOI 561b can support a thick atmosphere over a magma ocean, then some thermal signals we have used to label other close-in rocky planets as airless may need a second look. The implication is bigger than one world. We may have been underestimating how many scorched rocky planets are not dead surfaces, but active planet atmosphere systems. That changes the search strategy. Webb and future observatories are not just hunting Earth-like worlds. They are mapping the physics of survival across impossible environments. The question becomes less, can this planet host life? And more, what does a rocky planet become when the star tries to strip it apart for billions of years? and fails. If that reversal surprised you as much as it surprised me, leave a like, because a planet that may keep a sky over an ocean of lava deserves a little respect. There is still caution here. The Webb interpretation is promising, not final scripture. Exoplanet data live on model comparisons, noise treatment, instrument limits, and the awkward fact that distant worlds do not volunteer their secrets. Another team could refine the atmospheric retrieval, improve the phase curve fit, or argue for a rock-only explanation with different assumptions. That is not weakness. That is the real texture of science. Still, the broader insight remains powerful. We often imagine planets in binary terms. They either keep an atmosphere or lose one, either become habitable or become ruins. TOI 561b suggests a more unsettling middle ground. A world can be catastrophically hostile and yet physically persistent. It can lose the atmosphere it was born with and still generate another. It can look doomed from far away and under sharper light turn out to be chemically alive in its own violent way. And honestly, there is something almost human in that. Not because the planet resembles us, but because it reminds us how misleading the word impossible can be. We use it when our models feel neat. The universe uses it as an invitation to look closer. So the payoff is not that TOI 561b is secretly comfortable. It is not. The payoff is that rocky worlds may be tougher, stranger, and more dynamic than our harshest assumptions allowed. A planet orbiting every 1.4 days above a global magma ocean might still refuse to become bare stone. Whew. That means the map of planetary survival just got wider. And once you widen that map, you start to wonder how many other dead worlds are only dead by our old definitions. If worlds like TOI 561b fascinate you, planets that break the rule right where the rule should be strongest, subscribe. This channel is for people who like their sense of the universe expanded by places that should not endure and somehow do.